This is Mrs. Dawson. Write the piecewise-defined function shown in the graph. Let's begin with the left portion. Notice that it is a constant function of y equals 1, 2, negative 3. So the y values are always negative 3. And we want to identify the x values as well. Negative 1, negative 2, and then pointing toward negative infinity, which means x is less than negative 2. Notice that the circle is not filled in, which is why x is less than that value, not less than or equal to. The next piece of the piecewise is from the x value of negative 2 all the way to the x value of 4. Notice that these are filled in, which means negative 2 is less than or equal to x, which is less than or equal to 4. Those are our x values for this linear portion of the piecewise. The function, or y equals, we can find by identifying the y-intercept, which is at the origin, and then finding the slope. Up 1, right 1, up 1, right 1. So it has a slope of 1 and a y-intercept of 0. So this line, or line segment, is part of the line y equals x. The top, or furthest right piece of this piecewise is another constant function for the y value of 1, 2, 3, 4, 5. So y equals 5 for the x values of greater than 4. So x is greater than 4. Notice, once again, we have an open circle, so its x is greater than 4, but here there was a closed circle. X was less than or equal to 4. So let's put this information together in a piecewise function. So we'll use f of x for function notation, and we have 3 pieces of the piecewise. The function is equal to negative 3 for x values less than negative 2. The function is equal to x for x values between negative 2 inclusive and 4 inclusive. In other words, negative 2 is less than or equal to x, and x is less than or equal to 4. And then the last piece of the piecewise is y equals 5, or f of x equals 5, for x values which are greater than 4. We have 3 pieces on the piecewise and 3 pieces in the function notation.